Zeal Education Society, redefining excellence.
Zeal Education Society, Department of Civil Engineering, 2021. Prepare detailed report on common causes of cracking. Is concrete structure of your building. Group members: Durgesh Lambe, Anil Jadhav, Shreyas Bandhal, Sagar Vitkar, Preeti Pise. Guide name: Mr. Bagde. Cracks. Cracks in concrete buildings have several causes. They may show total extent of damage or problems of greater magnitude. They may represent critical structural distress, lack of durability, or they might influence appearance only. The importance of cracks dependent on the nature of cracking, any type of structure, causes of different types of buildings, cracks, and their remedies will be discussed below. Causes of crack in concrete buildings. The principal causes of cracks in a building are thermal movement, creep movement, corrosion of reinforcement, moisture movement, poor construction practices, improper structural design and specification, poor maintenance, movement due to chemical reactions. Permeability of concrete. As deterioration process, concrete begins with penetrations of various aggressive agents. It detects the ability of concrete to withstand weathering action, chemical attack, or any process of deterioration. Therefore, low permeability is a key factor to concrete durability. There are number of factors that control concrete permeability like water, cement, ratio. Uses of admixtures curing air avoids due to deficient compaction, microcracks due to loading, cyclic exposure to thermal variations, and the age of concrete. The first three are allied to the concrete strength as well. The permeability of cement paste is a function of water-cement ratio given good quality material, satisfactory proportioning, and good construction practice. The permeability of the concrete is a direct function of the porosity and interconnections of pores of the cement paste. Permeability of concrete. Remedial measures. The above discussion suggests suitable measure to decrease concrete permeability and hence cracks. Thermal movement. Thermal movement is one of the most potent causes of crackings in building. All material more or less expand on heating and contract on cooling. Ambient temperature changes and loss of heat of hydration in portion of structure at different rate lead to temperature variation and subsequent thermal movement. The thermal movement in a component depends on number of factors such as temperature, variations, dimensions, coefficient of thermal expansion and some other physical properties of material. Thermal variations in internal walls and intermediate floors are not much and thus do not cause cracking. It is mainly the external walls, especially thin walls exposed to direct solar radiation, and the roof which are subject to sustainable thermal variation that are liable to cracking. Thermal movement. Remedial measures joints shall be considered during the design and constructed properly. For example, expansion joints, construction joints, control joints and slip joints. You can see the pictures below. Creep movement. Gradual and slow time dependent deformation of concrete structure under sustained load is known as creep. It may generate excessive stress and lead to crack development. Creep increases with increase in water and cement content. Water cement ratio and temperature added to that add mixtures and polozone with increased creep. The increase of temperature in steel bars will increase creep as well. However, it decreases with increase in humidity of surrounding atmosphere and age of metal at that time of loading. Creep movement. Remedial measures use minimum possible quantity of water. Employ large coarse aggregate. Provide compression reinforcement if possible. Avoid firm work removal at the earlier ages. Cure concrete properly. Assign proper cross section for the concrete element. Corrosion of reinforcement. Reinforcement corrosion will produce iron oxide and hydroxide on steel bar surface. Consequently, its volumes increases. This increase in volume causes high radial bursting stresses around reinforcing bar and result in local radial cracks. These splitting cracks in the formation of longitudinal crack parallel to the bar. Reinforcement corrosion will occur unless it protected properly. Steel reinforcement can be protected by providing adequate impervious concrete cover. This will prevent the integration of moisture and other aggressive elements. Steel corrosion will also not occur as long as concrete surrounding it is alkaline in nature, having a high pH value. Corrosion of reinforcement. Remedial measures use low permeable concrete, provide adequate cover thickness, make sure concrete steel bond is as good as possible. This is because concrete alone is not capable of resisting tensile forces to which it is often subjected. Otherwise, concrete may crack and allow harmful substances material to attack steel bars. Moisture movement. Most of the building materials with pores in their structure in the form of intermolecular space expand on absorbing moisture and shrink on drying. These movements are cyclic in nature and are caused by increase or decrease in interpore pressure with moisture changes. Shrinkage can be of plastic or dry factors that cause cement or mortar to experience shrinkage. Include excessive water and cement quantity rich cement mixture greater shrinkage. Moisture movement. Remedial measures provide movement joints. Use minimum possible quantity of water for mixing cement concrete or cement mortar. Compact concrete properly. Vibrated concrete suffers lesser shrinkage compared with manually compacted concrete. Finally, avoid the use of excessive cement. Poor construction practices. These are broad variety of construction practices that lead to concrete cracking. Normally, improper construction practices are due to ignorance, carelessness, greed, or negligence. Main causes for poor construction practices: improper selection of materials, selection of poor quality cheap materials, inadequate and improper proportioning of mixed constituents of concrete, mortar, etc. Inadequate control on various steps of concrete production such as batching, mixing, transporting, placing, finishing, and curing. Poor construction practices. Construction overloads include during construction can frequently be more serious than those imposed during service. Inadequate quality control and supervision causing large voids, honeycombs, and cracks resulting in leakage and ultimately causing faster deterioration of concrete. Improper construction joints between subsequent concrete pours or between concrete framework and manure. Addition of excess water in concrete or mortar mixes. Lastly, poor quality of plumbing and sanitation material and practices. Poor construction practices. Remedial measures monitoring construction process properly. Utilize good quality material at the time of construction. You can see the pictures as below. Thank you for listening.